So the first thing is why are we talking about putting our schemas in normal form? That's the first question to ask. And I guess the answer is that anomalies arise. So I'll write down anomalies right here. Let's see, I have my trusty notes. I guess the most obvious one would be redundancy. I guess when we come to them, I'll explain what I mean by these things. Insertion, deletion, and one more. What was it? Update. I guess is very similar to insertion and deletion in some sense. It could become, I guess you could use these two to get update. But in any case, I guess the idea is to try and minimize the chance for error in your database by making your tables nice and foolproof, I guess, or as foolproof as possible. And so we're going to learn about, we're going to talk about 5 different normal forms. And really, in reality, maybe like 3, because 2 of them are kind of fake. They're not. But what's that?
Invented by graduate students.
No, I mean 2 of them are trivial, kind of, is what I mean. In any case, so I guess I'll start with an example to motivate it. So my example is this. I should say this is shamelessly ripped off from this great little survey on normal forms, circa 1982, that I'll post to you guys. So post up on the website later. But just to give credit where credit's due. Number 1 is, so my example is, let's say I have some inventory of parts in a warehouse. So part, warehouse, let's say, and I have quantity and warehouse address. Is that how you spell address? Yeah. All right, and what's the primary key here? The primary key will be the part and the warehouse. So for each part and for each of my storage warehouses, I list how many, of the part I have and the address of the warehouse. So this is obviously a dumb idea, right? Because I have to, what's the problem here? I have to, basically every time I update something, every time I have to put a part in my inventory, I also have to write down the address of the warehouse. And this will, A is redundant. I'm taking up too much space. B, even if I just want to insert the address of the warehouse, and I don't have any parts to put in yet, this thing is messed up. I don't have a primary key without a part. Right? So somehow, if I just doesn't let me put my address in there, it's not very nice. And also, conversely, if I delete a part, I might, the only part that's in a certain warehouse, I might get rid of its address by accident. Or if I change the address of the warehouse, I'd have to remember to change the address in every one of the entries. Right? So this is, inefficient for a lot of ways, or in a lot of ways. So how do I fix this? Well, I make 2 tables, right?
Is this the first normal form we're leading to?
Well, this is not even in first.
Okay.
No, well, I should say.
What is this in violation of? Which normal form?
Well, it's in violation of second normal form. This one doesn't even satisfy second normal form. First normal form is really stupid. Okay, so I'll just put it down here in the corner. All attributes are atomic. Like string, integer, etc. So I can't have, one of my columns be another table or something or some structure. So it's just sort of, it's not it's almost not worth mentioning because it's.
DBMS is prevented.
Seems to be the most important one.
Seems that, well, I guess it depends on how you look at it. Usually, that's what the revolutionaries always sort of throw away the most basic assumption. So I'm treating it as like a most basic assumption.
As we storm the barricades
Yeah.
of the databases.
Yeah, exactly.
It does also indicate, though, that you don't have multiple values in one cell. So there is, you certainly can make something that's not first normal form in a relational database.
Comma separated values in
Yeah,
one
comma
cell.
separated values in the same cell.
Okay, yeah.
So it's not like it's automatic.
Well, I mean, I wouldn't do it. Would you? All right. In any case, so what's a solution here? I guess I'm not going to define what second normal form is yet. I'll just write down what the obvious solution is to split these things up. Right? So I'm going to have, I'm going to have my part, the warehouse quantity, and then I'm going to have another table, which is the warehouse and the warehouse address. So this is bad. So now, if I want to change my warehouse address, I only have to do it in one spot. And everything is good. So before I define, so this is now in second normal form, and it wasn't here. But I should define a few things before I say what second normal form is.
What's this comma separated value thing?
What?
The thing that Michael asked about?
I'm sure there's like hacks.
Tax where you can put a vector in a
What's the
cell.
idea?
You can't
Well-
put multiple values in one. That would be I'm not, no, I mean, I'm saying you just can't put 4 names in one cell and like separate them with some, as a string that you would later extract. So you can't like put comma separated values in one cell and then process it.
Because you
Like,
can,
if you had a table,
but it would violate
Violate
first
the
normal
first
form.
normal.
So it's-
if you had a table person and dependents, and so person was somebody, and then dependents were son1, comma son2, comma son3, you could store that in a database, but that wouldn't be in first normal form.
So my question, so you can do that, you're saying?
Yeah,
It's the
one
database
is
won't
one
stop,
cell.
yeah.
Sure.
You can do anything you like.
Is there any limit to the number of?
Blobs can be.
It's not.
Yeah.
It's
You
not
can put
saying. It's not like there's a mechanism for it in the DBMS, or just you can do it as a string and put commas in there, and then you can parse them out on your own.
Oh, I understand.
That's all.
Yeah.
I understand. You're going to fake it conceptually, but as far as it's concerned, you're not faking it. As far as it's concerned, there's just one thing there.
One string.
Right. All right.
One good.
All right.
The question here was how is it possible to violate first normal form? And so that's still, yeah, that's violating. I mean, semantically, that's violating.
Okay, it's violating. Database doesn't know you're violating it, though. You're just the goofball throwing a big string.
Right.
Yeah.
Database isn't making any justice on your character anyway.
All right. So before I can define any more of these normal forms, I have to tell you what I mean by functional dependency. And I bet you're all eager, sitting on the edge of your chairs. All right. So if R. So if I have a relational schema, like the thing I just erased, for example. So an X and Y they don't have to be attributes, they can be lists of attributes. Well, let me pause here. So I hate giving the most general definition, but let me do an example first, and I'll continue the definition. So the example is, so warehouse is functionally dependent on warehouse address. So what does that mean? That means, you know, if I have a row and I tell you what the warehouse is, there's a unique choice for the warehouse address. Okay, so that's what this notation
But
means.
you said,
Did I say it backwards?
I think you
Yeah, I said it backwards. Okay, warehouse address is functionally dependent on warehouse. Yeah,
warehouse functionally determines.
you're right.
Well, it might be.
Probably 1-to-1.
It's probably 1-to-1.
Let's.
Not necessarily.
Whoa.
Yeah. All right. Anyway, so.
In any case, warehouse address is functionally dependent on a warehouse.
Yeah, warehouse address is functionally dependent on warehouse. Yes. I should write that down. So, I mean, it kind of makes sense linguistically.
Which means if you know warehouse, you know the address. What was it if you?
Yeah. Dependent on warehouse. So, yeah, if you know. So this uniquely determines warehouse address. Now, I should say this is a property. It's not a property of any particular set of data you have. Like it might be, you know, you might have some coincidental setup where, you know, like the price of tea in China uniquely determines, in your database, uniquely determines the price of the chairs, you know, being sold at ArsDigita or something. But it doesn't have to do with some coincidental data. You know, I mean, when we say functionally dependent, we mean sort of kind of abstractly in the schema before you get any data. All right. But in general, I guess I could have, you know, I could have more than one thing here, right? I could have a few attributes. If I know all of them, it determines a bunch of other attributes. So in general, these could be lists of things. And this is the notation that you use in the book, so I'm trying to stick to it. So if these are lists of attributes, X or Y means, you know, if T and S are, I guess, rows in the database, or rows in the, or I'd say just tuples. I'll just call them tuples. Then, you know, if they agree on X, then they must agree on Y. So that's functional dependence. T.X equals S.X implies T.Y equals S.Y. All right. Now, you actually know, you already have one example like this you've been dealing with all the time. And that is primary key, or just any key in general. I mean, that's the sort of most extreme example. So for example, let's say A is a key for some table, A, B, C. Then what functional dependency does that give me? It tells me that if I know what A is, it uniquely determines B and C. Yeah? All right. Or, I mean, you know, similarly, if you have some other table, S, A, B, C, D, and I tell you that A, B is the key, is a key, I guess. I'm not saying it's the primary key. Then I could write something like this, and that means that if I know A and B, I can figure out what C and D are. Okay, and these are sort of things you figure out based on, you know, properties you have of these databases. All right, so
Before you go on, I just had a question. I always say it like you say it, and a lot of people do, that when you have a functional dependency that A is functionally dependent on B, that you think that when you know B, then you can figure out A.
Well, you can look it up, I guess.
Right, but there's nothing implied in the definition that there's any kind of actual way.
Computational way. It's not. There's no function. You can't. You can't input the string, and like add the ASCII values. And is that what you mean?
Yeah, I mean that.
It's just an abstract sort of.
It just
thing.
means that if two of these things were the same, then the other column would have the same values too, even though there might not be any obvious way.
Yeah, this is not. Yeah. It's not dealing with any a priori sort of relationships that we can figure out. So it's not functional as in computation, computable function, I guess. Yeah, but that's a good point. Yeah.
No, just because I mean, I sometimes get mixed up when I think about it in a computational way, because I think things aren't functional dependencies when they are, because there's no way to obviously compute it. But there doesn't have to be any way to obviously.
No. Yeah, that's a very good point. It is, because especially using the word function is misleading. It's good old mathematical function.
For those of us without a math background.
What's that?
For those of us without a math background, it's not we can do with it.
Not confusing at all.
So anyways, now I can tell you what second normal form is, and that's pretty useless too. Everything's pretty much in second normal form, but it's not the interesting one. But the second normal form, excuse me, says that, so let's see, relational schema R is in 2NF if how can I say this? I guess if there's no, I should rewrite what we had. Multi-attribute key. We had the part, we had the warehouse was the key, and we had the quantity and the warehouse address, right? And the problem was we had this dependency where warehouse address was dependent on warehouse. Okay. Now, basically, second normal form says you can't do this. So there's no functional dependency FD from subset of I guess from subset of we have to be careful here. What word did he use? Candidate key? I think you use candidate key. I mean, here's my question. How have you defined key?
Oh, many ways.
All right, because you can define
Key is a potential key.
All right,
I
but
mean, could be. It's
is it
something
minimal though? Is it minimal in the number of attributes or no?
Or shouldn't it be that it's
Oh, otherwise it's a whatchamacallit key.
super key?
So, yeah. So you distinguish between super key and key.
Yeah.
All right. All right. All right. Then I can say there's no functional dependency from a subset of a key.
Any key.
Yeah.
Should be the case. There's no key.
I guess I should say
These can't
from some key. So the candidate key emphasizes that it could be a primary key. Is that how you use it?
That it could be
Could
not
be.
a primary.
Right, as long as.
Yeah. All right. I'll use candidate key then if no one objects.
Okay.
All right. So the problem here is.
So is this actually it is in 2NF if there's no functional dependency?
Yeah. Right. So this thing is not in 2NF.
But is your sentence stated correct up there? It is not in 2NF if there's no functional dependency?
This is in 2NF because there is no functional
I didn't say
dependency.
is in, I think it's in.
Is in. Sorry.
Here. Shocked.
All right. So basically, 2NF says that you need the key, the whole key, and nothing but the key, to be able to determine, uniquely determine things in generality. So you can't have some funky relationship here. And this actually brings us up to the heuristics that I could glean, at least, for dealing with these things. The general heuristic is that things that are completely independent should be in different tables. And, things, I guess if there's some things that are, so when you're breaking off the independent pieces, group the things that depend on one half together, so keep things that are really dependent on each other together, and keep things that are completely independent apart from each other. General sort of heuristic. But so in this case, there's a dependency here that's kind of bad. That this thing is really just dependent on that. So we should just move it up. That's what we did. All right, but that's kind of vague, so I'll keep on going. I didn't really define what I defined what functional dependence was. I didn't really define what independence was. So I have to do that. All right. Huh?
I wanted to ask a question to the class to give them something to think about while you're...
What's your question?
Why is it bad to have something that's not second normal form? Like, what could happen in your database that could mess up the database somehow? If
you came in late, didn't you, Shai? Yeah. No, but it's a good, good recap.
Looking back at my
No, but go on. What's bad?
Potential for data corruption, redundancy, insertion, deletion.
That's just, so what's a specific example that would mess up here? Like
that specific example of warehouse address.
Yeah, for example,
So in other words, under that schema, you need a part in order to insert a warehouse address.
Right.
You could insert two different warehouse addresses for the same warehouse, and you're taking up extra space.
anytime you add a part, you have to repeat the warehouse address.
Yeah, if you delete a part, but just and the warehouse is the only one carrying the part, you lose the address.
And if you change the address, you have to hunt down every place it occurs and change it.
Now, I'm not sure how many of those, though, are specifically related to the second normal formness. Are they? I mean, how many of those is it a factor that it's a subset of the key that's dependent on those?
Separate table,
But what if the dependence...
Well,
Would those still be a problem if the dependency was from, say, quantity to warehouse address?
Mm-hmm.
Well, that brings us to some other things. Well, okay, so I apologize. I don't have very many examples, and that's tough. So let's see. Let me write down. So there's two. What you bring up is something called 3NF, surprisingly enough, or third normal form. Okay, so let's write down this example. Let's say I have some employee list, and it has employee, department, and say location of department. All right, so this is this in 2NF?
No.
Why? Employee is the key. Here. So I have a little employee table, and I in my table I say where the employee, for every employee, what department the employee works in, and the location, the address of that, I guess address I should say. How's that? Address of the department. Okay, and my primary key is the employee. So that doesn't violate anything so far in 2NF. Okay, but still, this is what Chris was bringing up, that there is a dependency here. What's the dependency? Department to address. Okay, so this is actually, I should say, this is not in 3NF. I should. Now the question is, could this also bring up problems? Some of these same. Yeah, it has exact same problems. It's not. So that's why 2NF is kind of lame because, it's a little specific. I mean, there's the same. We get the same kind of dependency problems even if you're not dealing with your primary keys or keys in general. So, is department a key here?
No.
So just because I underline something doesn't mean it's the only key, right? But is department a key?
No.
Not really. I mean, not in most circumstances you can imagine.
No, because there would have to be one employee
Yeah.
per department. Right. Okay, good. What's that?
Saying keys.
Keys do not have to be unique.
Keys do? Yeah, what do you do?
Well, when you...
Unique
What's that?
key or uniquely identify it?
What do you mean by keys have to be unique?
I'm asking.
So in
The
the...
values of the key have to be unique. There isn't a unique key given a relation.
Sometimes you can choose... You could choose... Like if you have a big table, employee, social security number, other random ID number, blah, blah, blah. You could choose many different things to be the key.
Right.
Yeah.
But as long as you identify each row uniquely, you're fine.
Right.
Like if key identifies more than one row, then it can be.
Right. So, I mean, just in the way the book uses the word key, many things could be, possibly be a key.
Sure.
Yeah. All right, we're all on the same page. All right, so anyways, so this is not in 3NF. And you guessed it, so 3NF says, so it basically says no non-key to non-key dependencies, and 2NF also. Okay, and 2NF. All right, so this is a little stronger. Okay, it gets rid of a lot of problems. Now, there's something else which is very, very similar called BCNF. Okay, voice cod normal form. So let me draw this picture. So we have relations. There's 1NF, 2NF. I didn't budget well.
We should have Shai come up and do this.
Yeah, Shai.
Start from the inside.
Oh!
I've been converted. I do semicircles.
Start from the inside? All right, let me try that. Semicircles?
These are hierarchical, so things can't be in.
Yeah, the way they're defined. So
Should be a different color for each one.
so there's 5NF, 4NF, BCNF, 3NF, 2NF, 1NF. Relations. All right. So, and most of these aren't. I mean, these are the ones that are kind of interesting. Those aren't so interesting. So BCNF is right in between here, and it's the definition of that is that. So notice I said that whenever you have something that's a key, you automatically get these dependencies, right? So that's the definition of BCNF. Those are the only dependencies you get. All right. So BCNF. Voice cod normal form. So, he's one of the people who coined several of these normal forms, and maybe Boyce too. Cod, right? Yeah. Okay. All right. So basically, Boyce cod normal form says So the only dependencies are of the form key to stuff.
Within.
Huh?
The only dependencies within. That's
Yeah.
Kind of
Yeah. So yeah, none of this stuff really deals with intra-table dependencies or question?
If you have a table with, say, employee ID and then social security number and then address, that's not in 3NF?
Employee.
Social security number, so that they're both unique, and then address.
Okay, so
You pick the ID.
so the question is, so let's say I have employee ID, SSN,
And then address. Or phone number.
and phone number. So each of these could be, you're saying each of these could be a primary key?
Yeah.
So-
you pick one of them.
Now, this is a good question, actually. I didn't make it very clear. So let's say I pick this one. Is this in 3NF or not? So when I say key, I don't mean primary key. I mean any potential key. So it's okay. There are dependencies here, right? So these are all possible keys. What's that? All right, you're right. People could be roommates. All right. So employee ID, SSN are possible keys, right? So we have all these dependencies, SSN, E goes to phone, I guess SSN, E goes to S, E goes to P, S goes to E, S goes to P. Actually, you even have S goes to S, and E goes to E. You got to throw those in there too, if you want. But the question is, does this violate the definition? Apparently, it does.
Only, right? Because key-to-key functional dependency is or is not a violation.
All right. So this is where this definition is very misleading, I guess. If you're dealing with primary keys, this means any potential key. So these are all okay. This is okay.
Some things that are.
So
Wait, other things.
So basically, so this says non-key to non-key. Okay? Anything that's a potential key, whenever you have something that's a potential key, you automatically get those dependencies, because anything that's potential key will uniquely determine all the rest of the stuff.
Right?
Why isn't it in 2NF? That's a good
Because
question.
a subset, SSN, which is a subset of the key, or which is the key, points to P. The phone is dependent.
Oh, so 2NF says no proper subset. I mean,
Oh, okay.
not
Oh,
yeah.
right. Obviously, a full key.
The full key always uniquely, determines everything, and there's dependencies. Okay. So
I'm
basically,
not sure how you decide if something's functionally dependent.
well, that's the thing. It's not. It's sort of something you have to just think about. I mean, depending on your situation, you have to sort of look at it and say, well, these should be dependent or these shouldn't be. I mean, so part of it is guesswork, or maybe you could use statistics, for some things, like run a model and say, well, these really are dependent somehow. But we're assuming that that's sort of given from above. Someone else has decided that what things are functionally dependent and what aren't. We use some other reasoning ability to figure that out. Yeah. So, all right. So this isn't 3NF. Yeah. All right. So it's just when I say key, it means any potential key, anything that could be a key. All right. And again, how do you fix this thing? Break it up again.
You always fix it.
Fix it by breaking it up. Generally. But what's a trade-off, though? If you keep on breaking things up,
Then you always have to join.
right. So like, there is a potential trade-off here. You could. split things up and then pay the price later if you're going to have to do a million joins, all these like minuscule tables with lots of, or a few columns, and so there's trade-offs.
Dimitri?
Yeah?
Wouldn't the E to P dependency be a non-key to non-key dependency that's in violation of 3NF?
Well, okay, it's not doesn't say non-primary key. It just says non-any key. E is a potential key. Employee ID, so I'm saying keys, so potential keys. So I'm not saying primary key. So keys here, the keys here are candidates. So EID and SSN. So primary key is SSN.
By choice?
Yeah, I just wrote this underline here, I guess. I'm sorry. I should have said what I meant there. All right. So again, how do you fix this? You break it up. So again, now what do we have? We have employee, department. So we have two tables. We have that, and then we have department and department address. So same kind of thing, actually. Okay, and now this is fine. I don't get any bad dependencies. Okay, and this kind of makes sense, right? Nothing. You haven't learned anything new. Right? You guys are all good database programmers and would do that anyway.
So on this BCNF, this thing about key to stuff, in other words, you mean stuff kind of logically connected to the key, is what you mean?
Any stuff. Basically, it doesn't really matter what's on here, because once you have a key, you can get everything else. I mean, that's by definition.
So stuff is non-candidate key.
Anything. Anything. I mean, here I could
on
put.
that side, it can be anything.
It could be anything. I can put E goes to E. That's a valid dependency. I mean, it's silly, but
Redundancy isn't really a criterion here in these forms.
you're saying, well, there is redundancy. Is there a redundancy here? There is redundancy in the sense that, like this is redundant because this address gets repeated.
Well, let's say you just made up two columns that are identical EID. Is there anything in these rules that eliminates that?
Oh, you mean in this problem here? Two things that are identical.
Later.
There's nothing in.
Isn't one of the later normal forms not having the same information twice in a table or something?
Yeah.
Is that right?
Yeah. Let me think about that. Let me just. So you mean having exactly the same copy?
Is that eliminated for the rules?
I don't think so, actually. I don't think so. Idea? If I had another fake FEID with the same numbers, I don't think I can get rid of that using that. That wouldn't violate 3NF. No. No, I don't think so. No.
They each depend on each other, right?
Yeah. But that's fine.
They're both candidates.
So A goes to B, B goes to A.
Yeah.
I think that's all.
You don't think that's allowed? Well, we're in big trouble. No, that's got it.
I'm not sure.
Pretty sure that's allowed. Yeah?
I'm not sure I quite get the difference between third normal form and voice cod normal form.
There's a very subtle difference.
Can you give an example of something that's in third normal form but is not in voice cod normal?
I will. I don't have one prepared here. But basically, the subtle difference is, actually, I'm glad you brought that up. The subtle difference here is that you can have dependencies of the form, something of a non-key to a key dependency in 3NF. 3NF is slightly weaker. And So that's sort of, it's kind of implicit in the way this is written here, that the only dependencies are key to something, whereas there I could have non-key to. That's not. So it's kind of weird.
I
And
understand what you're saying,
but yeah, I'll come up with an example in.
I from Shy have an example that I can.
Well, let's just do it in recitation because it'll probably, be the best thing to do. But in any case, I mean, the only reason. Well, I'll try and elaborate on this more. I mean, there's this is more natural to sort of define BCNF, but this is easier.
It's not really clear to me what these non-key dependencies are you want to avoid. What anomalies do they be?
Well, these things like this. Well, they're just the same anomalies as before.
Just in general?
Yeah, yeah. So that's why, I mean, the book just starts with 3NF. There's no real reason to talk about 2NF. So, but I did.
I just don't see how a key can depend on a non-key. That doesn't make sense to me.
Or part of a non-key. Well, let's talk about it later because otherwise I'll spout gibberish. You don't want that, do you? All right.
Part of a key.
What's that?
It could be a subset of a compound key that's on the right side of that. Probably still violate, or still satisfy 2NF, but violate BCN.
Yeah. I guess the last thing I want to talk about is the other type of problem that can come up. We have dependency here. The other problem is independence. When you have things that don't really have anything to do with each other in a table. So this is called, I guess the fancy word is multi-value dependency. Well, I'm not so sure I like that word. Okay, so what if I had a table like that had, say, an employee again, and that's, well, the list say what the employee can do, their skills, and also what languages they speak.
Wait, the employee's a key in that table?
Well, here's the question: what's a key here for this? I'm gonna have a table. It's a list of, for every skill I can think of and language they speak, I'm gonna put something in this table.
It's going to be all three.
All three, right?
So we have comma separated values in skills and languages.
Zero number for us.
All right, so pretty much all three of these things are needed. Now, but what's the problem here? The problem is that somehow these are not related at all. So what am I going to do? Like, I have to have a convention for how I'm going to deal with. So let's say, so Bob can juggle and speaks French, but also speaks English or German. I don't know. What do you do here? Like, so say that's the only skill Bob has, but he speaks a lot of languages, Spanish. So what do? Either you have to have blanks in here, which is a problem, or what's the other thing you could do? You could just repeat, right? Somehow. Both are problematic because of this. These things have nothing to do with each other. Somehow we get this repetition. It's kind of like we're joining these things when they shouldn't be joined or something. These tables, right? So this is bad, and we don't like it. So the question is. well, I guess what I want to do, the rest of what I want to do right now is to define, what do you think it would mean for two things to be independent?
In statistical sense, the knowledge of one does not affect what your guess of the second one would be.
Right? So how do we translate that into a
Relation.
Yeah. Well, maybe we should just say it in words. So what would it mean for these two things are independent. So how could I phrase that? Like, how could I tell a computer to recognize when, or maybe that's not right way to say it.
It's not an empirical issue. You can't analyze the table.
No, you can't analyze the data or the table. But how could I sort of, what kind of definition could I give to it?
Just that there's no functional dependency from one to the other and vice versa.
Oh, that's interesting. I never thought of that. That might work, but that's not what I was thinking of.
Just that they can all occur together.
Yeah, that's what I was thinking of. Basically that if you give me two things are independent, if like if I pick one possible value from one and one possible value from the other column, that I can get any pair. That's allowed. So if there's nothing constraining me against doing that, then things are independent. Now, I guess that's the same as no functional dependencies if you really think about it.
No.
All right.
I think you're saying you want every single possible
Well, not that it exists in the table.
But that you should allow.
It's Yeah, it's not. There's no restriction against that.
But I think you could restrict some of those and still
Well,
not have functional evidence. I don't think the definitions are clear.
you're right. Shai is right. Shai speaks the truth. So. So you could have two things that are not functionally dependent in some freaky way. That's not as general as this. So the definition of two columns being independent is that one could show up, like if I pick one from first column and something from the second column, there's no restriction from both showing up.
The definition that Dimitri said is
Yeah.
stronger than the one that you see. If you can have all these independent possibilities, then for sure there's no functional dependencies between them. But it's possible not to have functional dependencies between them, and still not to allow every single combination.
Can you give an example?
Yeah, I don't see the truth of that.
I will
Ah.
try to write one.
All right. Well, let's see. What would I like to do now?
I guess if one of them doesn't determine the other one, but it narrows the range of the other one, that kind of thing.
Is it true to say that you avoid all these
Only
problems when you
Europeans
don't
juggle.
duplicate data?
You can only speak the romance language.
What do you mean by don't duplicate
Maybe
data?
it's sort of a squishy definition, so that's why we need all this.
Yeah.
So how about you just don't do? I mean, if you have information that you'd say the same thing in the same situation, you avoid saying the same thing in the same situation by putting it in another table, so it doesn't duplicate.
Generally, but then there's problems. There'll
that's
be
why-
problems.
So
Yeah.
So it's almost like you do a join and it's the same thing as a cross product.
So we're trying to think of an example where there is a relationship between them, but one value doesn't determine the other value. Is that right?
Well, I would
So
save
if-
that.
How about if you had age type and then age, and age type could be either days, months, or years. So someone who was 73 would have age type Y and then 73, and a baby that was 6 months would have M and 6. M doesn't determine what the value, well, I guess you'll have different realistic ranges, but M doesn't actually determine which between 0 and 12 is going to appear in the second field. And similarly, age.
Yeah, but it does tell you that it's between 0 and 12.
Well, that's your constraint that you're imposing.
Right.
But, I mean,
So that is some sort of...
It's not a
Well,
one-to-one.
that's not, yeah.
Is that a functional dependency?
It's not a functional dependency, I guess.
But it is.
Yeah,
limitation.
yeah,
But it also-
absolutely.
So there's a relationship.
Yeah,
There's some
there's
dependency, but it's
functional
not a
dependency is very strong.
dependency.
Very, very strong. So you're absolutely right. Good answer.
Makes sense.
Good answer. In any case, I guess I have I'd like to work out some more examples, but I think it's probably best to wait for now. And